Okay, you see my slide now.
Yes, Professor.
Yes, yes.
Okay, so starting again. So sorry for the problems of internet. So and now we want to say that today we will learn about what is the neural network and what's the reasons why you need to study neuron computations. Okay, go ahead to see here why we need to study neural networks. So the first thing is that to understand how the brain, your brain, human brain actually works, and to understand the style of is called parallel computations. It means they like a network with the parallel to compute. And sorry, and the last one is called we need to solve the problem, practical problems, by using a novel learning algorithms that you no need to solve the problems method. The method of solving problem is no need to know, but the only standard method is called neural network. Any problems, any status, any practical issue can be solved by only one single standard. It's called neural network. This is a very good advantage of them. First of all, I would like to show you about a typical neuron that occur in your human brain. You can have the node, it's called axon, and you can have the something like a connecting a connecting line is called, and you have body, and you have something like a dendritic tree. So this is a human neural network, and when they want to communicate, they will generate the spike. You see, the spike is a pulse signal to another node, and then they is very uh, very fascinating because they can produce the output in the your experience, because they correct every experience into the weight of the dendritic tree and combine it like an axon node and body. This is a human, and some scientists try to capture the human behavior here and try to make this behavior like a mathematic. It's called artificial neural network, but this one is a neuron. So when a spike of activity travel along an axons, they alive to the synapse. At the synapse, they try to collect and sum everything to become the same one value, and then have the bias and everything there. The effectiveness of the synapse can be changed. They can vary the number of transmitter, vary the number of receptor molecular. So the synapse is very slow, but it have advantage over the lamp that is have like a very small and low power and can adapt locally available signals. Okay, this is a synapse inside of human. So how the brain works on one side. So the brain work is look like each neuron receive input from the other neurons. You see, the node, the black node is a neuron. So you can imagine that every node have the output, and the output sent to the another node. Okay. So the effect of each input line on the neuron is controlled by a synthetic weight. So the red node is called the weight. So where the weight is corrected in the synthetic weight. Okay, and the synthetic weight adapt when you have learned from the environment, and actually the brain of you have about 10 power 11 neurons, and each one they have about 10 powerful weights. You can see there is really much computations, and why the human is very intelligent, because they have many of neuron, and many of each neuron have many of weight. Okay, so the weight is a know-how is collect experience to the humans. Okay, that's one is why the human is intelligent, because their neuron, our neuron is very high, number of neuron, and number of weight is really high as well for each neuron. So okay, we can try, or scientists try to model things that we have to idealize them. The first thing that we cannot have computer that have many neuron like as human, or weight like as human, but we simplify the neuron model to be the mathematics, and try to understand the model that we cannot achieve like a human, but we can try to make something look like the human, and use for the simplify problems, because the human problem is very intelligent and challenges, but the some mathematic problems or engineering problems, it is not complicated like as human problem. So that's why we can apply our artificial neural networks to our engineering problems as well. So this one, so please see it carefully. So if you see this one, okay, this one is a neural network. It's called linear neuron. So this is the main equation of neural network used in uh, all of study. Even you are deep learning, even you are machine learning, supervised, unsupervised, linear regressions, or any of is called uh, backpropagation neural networks. So you still use this main equation for neural networks. So let I talk to this one. This one is like you have uh, x. X is the input. The x can be real input, or the x can be uh, the output from the connecting node of that neural network. So x means the input of the neuron, and weight wi is the weight of that input of the neuron. So each input of the neuron has its weight of the neuron, and this weight it can be adapt or change the value to according to your training set. And you can the output of the neuron is came from the input multiplied with the weight. And if you have 10 input, you can have 10 weights values, and you multiply input and weight and sum them together, and then you plus with one bias. At this moment you can get the output y. So the linear neuron, they don't have any activation functions. They just only put this value as the output. This called linear neural network. Anyway, we don't have only neural network linearly. We have many of neural network with activation functions. This one, the activation function is linear, but we have 10 sigmoid functions, 10 sig functions, exponential functions, binary functions, and we have, I think, almost 10 functions as the activation functions. We have to study them later. But okay, today I will show you about linear activation function first. So for example, if you have the input and you have the output and you have the specified weight, you can have something like a linear like this. And this one you don't have bias. Okay, you can have the bias. You can skip if you have the bias. In 1943, so some engineer and scientists that first compute with some of the input, and they try to uh, make the one threshold. If the value of the weight, some weight multiply input and some exceeds the threshold, they put the output of the neuron as 1. And if not, they put the output neuron as 0. So this one is called binary threshold neural networks. Okay, now today you have studied two types of neural networks. The first, the output is a linear combinations between bias and the summations of the multiplications of weight and input. Okay, this one, this one. And the second I taught you today is a binary threshold neuron. It is forms if you have weight multiply input plus bias, and it is over the one threshold value that you specify that them is, right? So it's become number one output, and the other becomes zero. So this is called binary threshold neuron. If you have z equal b plus sigma xi wi, or if you have z equal to sigma xi wi, and if the z more than or equal to theta, where you specify the value of the theta, the output become 1. Otherwise, becomes 0. Or you can try set the threshold as the minus b. If the threshold is the minus b and you pass b to here, so if the z more than or equal to 0, so y equal to 1. Otherwise, equal to 0. So now I tell you about the equations of two neural networks today, the linear, and the second one is the binary threshold neurons. Do you have any questions about this one? If no, I go ahead to this one. It's called rectified linear neuron. So this means if you have the set equal to b plus sigma I xi wi and set more than 0, so it's become linear, you see? But if the set is less than 0, so it's equal to 0. This one is called rectified linear neuron because you have only the positive value. You don't have the you don't have the uh, uh, you don't have the negative value of them. If you imagine about rectifier, I'm not sure you came from electrical or not, but if you have known about rectifier, uh, so the rectifier they try to make the some sine wave become only the positive value of the sine wave. Okay, if you from electrical, you can imagine about rectifier circuit. So the next is called sigmoid neural network. Okay, the same things like as a linear. You can compute z equal to b plus sigma x w. So if you can calculate the set now, the set is not output directly, but you substitute the set to this equation on the right hand side equation. On the right hand side, you can see y equal to 1 over 1 plus exponential of minus z. So if you substitute z to be these equations, you can get the y. So you can see the graph under the graph here, y and z. You can see the graph like this. It's called sigmoid function. Activation function is a sigmoid, and this called sigmoid neural networks. So I tell you one thing. Our brain, many of neuron of us is the sigmoid. That's why the scientists try to make this function for artificial neural network. Okay, this is all the lecture about neural network today. But okay, there are many of neural networks to tell you. Uh, okay, the type of learning tasks today, I would to tell you about. We have three types of them. First is called supervised learning. You need a teacher. You need the pair of input and the target output. The second is called unsupervised learning. You no need to have the input output or training set, but you have to tell them what the distance of what the criteria you want to separate between groups. And the last one is the reinforcement learning. I told you before today that reinforcement learning is look like that you have reward function. if you put some action to the environment and the environment action back to you like a reward or penalty functions, you can adjust your program or your brain by yourself using cue learning values. So it is not easy for learning this subject, but okay, I would like to tell you that reinforcement learning is very look like human learning anyway, because human is use the time very long to learn, is long life learning. So the reinforcement learning is not good for practical today because it's use the time too much for learning, but it's very intelligent. So okay, today when we're talking about neural network, we try to move to the supervised and unsupervised learning for the first target of my teaching about neural network. Okay, now, so what's meaning of the supervised learning typically work? So we start to use the model classes, like as you have the training set T, and you try to find the function f like as a neural network and the node. And if you try to find the function that one, you try to find the function of neural network that try to minimize the one a half of y minus t square. So why is the actual output from neural network? T is the target that you teach them. So if the difference and square of them is very low, that means your neural network is look like you or look like the trainer. It means it's good for this one. So this is the target of neural network in terms of supervised learning. So do you have any question or something to ask me about the neural network I taught you? So, okay, I have one question to you and give you about uh, 15 minutes to do this one. So, okay, please try to do this one. Sorry, it's like a, uh, I hope that you see my slide. So I have one neural network with my input is 0.5. You see xi is a 0.5. The second input is a 0.8. The third input is a 0.7. And 0.5 has the weight is a 0.6. 0.8 has the weight 0.7. And 0.7 has the weight 0.4. And I have activation functions like a sigmoid. So please find the y of my neuron. I give you 10 minutes from now to do this one. Okay, do you have any questions? อันนี้เป็นแบบฝึกหัดนะครับที่จะให้ทำนะครับให้นักศึกษาผมมี neural network ซึ่ง xi เป็น input นะครับมีค่าตรงนี้มี input 3 ตัวนะครับแล้วก็มี weight แบบนี้นะครับแล้วก็ผมจะให้ไม่มี bias นะครับจากนั้นมี activation function เป็น sigmoid ให้น้องทุกคนและนักศึกษาทุกคนหาค่า y ครับลองดูนะครับโอเค please try to find the y within 10 minutes from now I will solve for you later
อาจารย์ครับ
ครับเชิญครับ
I would like to ask that the input the first one is 0.5, second one is 0.8, and the third one is 0.7.